Hello. Today we're going to learn about linear regressions, nonlinear regressions, and the Antoine equation using Colab and numerical Python. So what we're going to do is we're going to start by getting our data. And to get our data, we're going to say wget exclamation point, and then we're going to find the raw file of our data. This was found on GitHub. These x values, these are all going to be our temperature. And all these y values, these are going to be our pressure and Ka, Pa. There we go. And we're going to run this. Enter. And yes, this should get us our data that we need. Then we're going to load in our data. So we're going to say data equals np load text of our file, water vapor pressure dot CSV. Looks like you got that from up here. And then we're going to give it a delimiter. So it commas out our x and y values. So we're going to say delimiter, and it's going to be equal to just commas in between. That should be good. And then we are going to actually, first we need to input numerical Python. So let's actually do that. Let's shift this one up. So we're going to say numpy or import numpy numerical Python as np. We're going to say from plotly dot subplots. Start making our plot. We say import make subplots. Yes. Okay. And then we are going to input our data and tell it which line it's going to be, 0 or 1. So we say our temperature is on line 0, and that should be data of 0 or comma 0, and then our pressure should be log of our pressure, which is going to be equal to log 10, I think it's np log 10 of our data, which is going to be in the 1 file. So comma 0, or no, 1. And that should be good. Now we are going to make our graph. So we're going to say fig equals make subplots. And we're going to say we want rows equal 1. Oh my God. And then columns equal equal 1 as well. And we're going to say fig dot add scatter, which is going to help us build our scatter plot. Now we're going to add our data. So our x is going to equal our temperature, and then our y is going to equal our log log of p. And then we're going to say that our mode is going to be equal to markers, and our name is going to be equal to data. Okay, let's see if this will graph. Let's make subplots is not done. Let's try to run. Let's try to run it all. So we've got some more errors here. Plotly.io, import plotly.io as PO, and we're going to try to make this dark. So we're going to say PO dot templates dot default is equal to plotly underscore dark, and we'll see if that works. No. Okay. Let's see. It's case sensitive, so maybe this could be a lowercase x. What we did wrong, that's correct. Okay, perfect. That's what we did wrong. So here's our graph, and this is very accurate to what the pressure says it should be. It's about 7.33, looks like, up there. It's good, in the thousands. Yeah, looks great. Okay, now we're going to change the size of our graph. We're going to say fig layout, width 600 and height is going to be 600. And I've changed my camera so it's in the middle of the screen, or my coding, so it's in the middle of the screen, so if I look up and down, it doesn't look like I'm moving left to right. So hopefully this helps, but I'm trying my best. So what we're doing here is we have our graph, a lot of different points on the scatter plot, right? And we've drawn a line through the middle. And what we want to do is get each of these points closer to the graph. And the way we're going to do this is by making what's called a sum square error. And what this is going to do is take these small derivatives from the graph, deviations from the graph, and make them closer to the graph, or to the line that we've made, the regression. And the way we're going to do this is by making a sum squared error. By taking the Antoine equation, which is log P of your pressure equals A minus B over T plus C. And what we're going to do is make a sum squared error. So we're going to take the sum, n, we're going to take the sum of this and say log P subtracted by our A minus B over T plus C. What we're going to need to do is square this to make all those deviations positive. So we square that. And this is what's going to get us those deviations. We're going to add up all those deviations, get them closer to the graph. And what this sum squared error is going to depend on is changing A, B, and C, and getting different test values for those. And we'll see how to do that later. Now we are going to define our sum squared error. So we're going to say define sum squared error of our V, and we are going to do that. There we go. And we're going to say V is equal to A, B, C. No, not C. And then we are going to make our Antoine equation. Now we are going to return our NP sums. We're going to say return NP sum. So we're going to sum up our Antoine equation, and we're going to say log of P minus A minus B divided by T plus our C, and all of that should be squared. Squared. That should be good. Should be work. You might need to add another parenthesis here. And after this, we're going to make our nonlinear regression. So we're going to add a line of code, and we are going to say A of our nonlinear regression, and B of our nonlinear regression, and C of our nonlinear regression. That's going to equal our minimize function, which we'll look at later. And it's going to minimize our sum squared error, and that is going to be and then we're going to make our guesses. So it's going to be 1. I think we should start with 1, 1, and 0 should be our guesses for now. We're going to come back up and use a function that we got from SciPy, and we're going to say from SciPy dot optimize, we are going to import minimize, and that should minimize our sum squared error. Now we're going to add the scatter plot of our linear regression. So we're going to say fig.add scatter is going to give us the same thing. X is equal to our t, and then our y is going to be equal to our log p, and then we are going to say, or no. The y is going to be equal to our Antoine equation using our nonlinear regression values. So we're going to say a of our nonlinear regression minus b of our nonlinear regression. B of our nonlinear regression is going to be divided by t plus c. Oops. Can't see the keyboard. T plus c of our nonlinear regression, and that should be good. And then our mode is going to be lines, and our name of the graph should be another comma. Name of our graph is going to equal Antoine nonlinear regression. That should work. And then we're going to come up here, and we're going to say restart and run all. This works. There's something wrong. Layout object is not callable. So what this is saying is that the layout object is not callable. So what we're going to do is we're going to say we made a mistake here, so we're going to say update. We're going to update our layout to make it the right size that we want. And this is saying the SSE, our sum squared error, is not defined. So we're going to say switch it around to say A, B, C equals V. And that should help us out a little bit. So it's runtime, restart and run all. Yes. Okay. So we have another problem. Unexpected EOF while parsing. Okay. Return NP sum of log P. Maybe this will do it. Let's say restart and run all. Yeah. Let's see if that helps. Okay, that one worked. And what's wrong here? Too many values to unpack. Expected 3. Looks like there is 3. A, B, C, and then 1, 1, 0. Too many values to unpack. Value error. Let's try to add a .x after this. See if that might help anything. Show it that that's what we want to see. Maybe. There we go. Perfect. And this is way off because our first values, our guessing values, our A, B, and C that we guessed with are off. And I'll show you how to fix that later. So now what we have to do is turn this nonlinear regression into a linear regression. And we're going to start by multiplying by t plus c. So that's going to multiply by our log p on one side, and then by our a plus b, or a minus b. And then we're just going to multiply out. So it's going to turn into our log p equal a times t, or sorry, t log p, up the front, t log p times our at. That's going to be multiplied by, that's going to be subtracted by our c log log p, and then that's going to be added to a c minus b. And we have this a c minus b. This is just a constant that we are going to turn into a d, as you can see. So you have your t plus c on both sides. This takes it into 8 times t minus c log p plus ac minus b, and that's just going to turn into our variable d. Now we're going to make our matrices, which our first one should be just our t1 and then minus log p1, and then just a row of 1s. We're going to have t2 minus log p2 all the way down to tn log pn. And we're going to multiply that by a, c, and d here. And that is going to equal us just t1 log p1 down to tn log pn. And this is going to be our x, this should be our y, and this is going to be our b vector. Okay, now we are going to work on coding our matrices. So we can add a line of code and move it down. Perfect. Okay. So this is where we want our code, and now we are going to code our matrices that we just made, our design matrix, and all that. So we're going to say x is equal to np c of it, and we're going to say t, which is our first value, our negative log t, and then we're going to do our rack of ones. So np ones like t, I believe is. And now we are going to add another line of our code, and we're going to put in our linear regression. So we're going to say it with, instead of ABC, we're going to do ACD. So A of our linear regression, C of our linear regression, and D of our linear regression. And we're going to set that equal to NP linear algebra. Yeah, linear algebra, and do the inverse of our matrix. And so that's going to be our design matrix. And then the multiply is the @ sign. And then we're going to multiply that again by xt again. We're going to multiply that matrix-wise by t times our log of p. And that should be just right. I'm going to say b of our linear regression is equal to, define, because we lost b, so we're going to say our linear regression, and we turned it into d. So a of our linear regression times c of our linear regression minus the d of our linear regression. And that should be good. And now we're going to look at what are those values. We're going to say a of our linear regression, c of our linear regression, and b of our linear regression. And we're going to see what those are. We can do A, B, C, B, linear regression, and C for linear regression. And we're going to shift enter. A of our linear regression is not defined. A of linear regression, C, D. I think we might have forgot to define it up above. Let's see. Looks like A linear regression and all of these are not defined because this inverse is incorrect. It should be INV. And enter. X is not defined. Let's try to restart. Restart runtime. There we go. Okay, perfect. So this gives us good guessing values for our graph. So we have 10 at A, 1771 at B, and negative 34 for C. So 10, 1771, and negative 34. So let's see what that does. 10, 1771, and negative 34. And let's see if that does anything. We didn't. We might need to add a t-plot. So now we're going to add a t-plot down here. We're going to add a new line of code after this one. There we go. We're going to say t-plot equals np line space np dot min of t np max of t. This is going to get our mins and maxes. P, double check, and 100. Okay. So let's see if this will do anything for us. Restart and run all. Yes. Okay. So we messed up here. Linspace? It's not line space. It's linspace, I believe. Linspace. Enter. Okay. Oh, where'd our graph go? Let's run all. Restart and run all. Okay, perfect. Okay, so that did not help too much in our guessing. Maybe it might be something wrong with our equation. Say, okay, there, yeah. So this is also wrong. So here we go. Add another one, I believe. Should help it. Here we go. Awesome. So we had our equation just a little bit wrong. So here, our guesses were a lot better this time based on our linear regression and our design matrix. Yes. Okay. So now we're going to add our final linear regression plots. We're going to say fig, add scatter again, and our x is now going to be our t plot, and our y is going to be the same thing we had earlier, but with linear regression values instead of nonlinear regression values. So a minus b, the linear regression divided by our t plot, which we just made up there, our t plot plus the c of our linear regression, and this should be good. And our mode is going to be lines, and our name is going to be no. And no. There we go. Name is going to be Antoine linear regression instead. No. Yeah. So let's restart and run all. And here's our scatter plot. So this has both the nonlinear and linear regression on it, this last one. And let's zoom in to see, if these are really that much different. They are. They're very much different. Two different separate lines. Our linear regression is in the green and our nonlinear is in the red. And our linear regression is going to be more accurate based on the inverses of our design matrix and everything. This would be just us guessing, and the guess is not as accurate. So thank you for learning about our linear and nonlinear regressions based on the Antoine equation and the use of water pressure data. Thank you. Have a nice day.